Alright, in this video I'd like to just show you how to set up and use a formula that's another variation of exponential growth. It's just a slightly more advanced variation for a little bit more complicated situations. Now as you look at this formula right here, okay, it looks basically like what we are used to with exponential growth, but I've got this extra variable in there, this n, and it shows up in two places. Now everything else is the same as before, but n represents how often something is compounded. And that is a financial term. And the best way I can put it is basically how often is this amount recalculated. Okay, sometimes the word amortized is used, but for most people getting just started in this, you want to think about how often is basically whatever interest you are earning added back into the pool and becomes part of your principal. Okay, how often does that occur? Is it once a year? Is it once a day? Is it once a month? What might it be? And there's different things, different typical frequencies with which investments of different kinds are compounded. Okay, they might be compounded annually. Okay, and if you see that in a problem, compound annually means once a year, so n would be 1. Okay, if you see quarterly, that means it's 4 times a year, basically every 3 months. And that's pretty common in the financial world. So n is going to be 4. Okay, and as you keep going on, you kind of figure this out. You have monthly, you may have weekly, daily, whatever. Okay, it could be a lot of things. And eventually we'll get into something called continuously. Okay, but right now we'll just deal with this particular formula. So, for example, if I say I took $1,000 and I invested it, so that's my principal, and it was compounded quarterly at 8% interest, then I would say this is 1 plus 0.08. Remember, I still have to change my interest rate to a decimal, so 8% would be 0.08 divided by 4 if this was compounded quarterly, and I raise that to the power of 4 times t. So if it was, say, for 10 years, that'd be 4 times 10, which would be 40. Now, just a couple of quick notes. Rather than go through this whole calculation and give you some decimal, you can handle that on your own, but I want to point out some things that students usually do in their rush to get through a problem, and then they get a value that just doesn't seem like it fits. The amount of money just doesn't seem right. So let me make sure we understand order of operations, especially if you're using a graphing calculator where you can type everything in at once. Okay, if you were going to do that, you need to make sure, first of all, that this is put into parentheses. It depends on the calculator you're using. It depends on all the differences between some of these calculators. But let's just make sure that you take 0.08 divided by 4, and you get a value for that. In fact, it might be best just to do that part and get that value to start with. Okay, now, as you do that, make sure you also have parentheses here. Whatever this amount is, basically we're taking 8% for the entire year, dividing it to 4 equal pieces, and then every 3 months, one of those pieces is added into your $1,000. Okay. Now make sure you add that number to 1, and then probably the most important thing that I see students do all the time is they use this little caret thing to be their exponent, and then that part they don't put in parentheses, and that's wrong. Make sure you put that in parentheses also, or just do it in your head if you can. Okay, because sometimes you type things into a calculator one way and you're expecting a certain result, but the calculator doesn't interpret what you think. It goes strictly based on order of operations. So this whole thing, if you could do a little bit of work in your head, you would see that this is 1,000 times 1 plus 0.02. If I took that divided by 4, I'm going to get 0.02, all to the power of 40. Okay? I think it's much more useful to do a little bit of math in your head and not rely on the calculator so much, so that you at least know you're getting the value you're trying for. You know you're headed the right direction. Okay, this would end up being 1,000 times 1.02 to the 40th. You type that in, there's no room for error right here. You try and do this all at once, you miss a parenthesis somewhere, and it takes a completely different turn that you're not expecting.